Welcome, and thank you for being here tonight. This is Boring Mathematics for Sleep, and I'm your calm guide through the hidden wonder of pi, the humble Greek letter that holds the key to circles, mystery, and centuries of sleepy curiosity. Tonight, let your eyelids grow heavy. We'll take a slow journey, not through dry formulas, but through time and across ancient sands. We'll meet scribes, scholars, and dreamers who chase the shape of a perfect circle. They'll whisper to you, in the hush of midnight. So lie back, breathe, and listen as we begin with the earliest stirrings in human history, when people first asked, what is the measure of a circle? Picture this: a quiet workshop in Babylon, about 1900 BC. Mud tablets, worn tools, and the low glow of tallow lamps. A scribe named Muru Ili, or someone like that, picks up his reed stylus. He presses it into wet clay, drawing a circle, and the numbers that describe it. Babylonians, you see, had a clever way of doing math, even without fancy calculators. They looked at circles and reckoned, it's about 3 times the diameter, plus a little bit extra. Their calculation, 3.125, was more accurate than the 3.0 they could have used. It was enough to build temples, measure fields, and trade goods. Floating in the dim glow, the scribe reads aloud, let the circumference be 3 1/8 times the diameter. The clay crackles and the line is pressed forever into human curiosity. Shift forward a few centuries, Egypt, around 1650 BC. At a temple near Thebes, a priest records instructions in the famous Rind mathematical papyrus. It reads, if the diameter of a circular field is 9, then its area is to be taken as the square of 9 minus the 9th part thereof. More gently said, subtract 1/9 of the radius square, then calculate, and you get a workable estimate. It's not yet pi as we know it, but it is humanity's early love letter to circles. Can you picture the scribe, his robes whispering on limestone floors as he writes, take the square of the diameter minus the 9th part. You almost hear the dusty papyrus stir when he rolls it up. Both civilizations, Babylon metrology, Egyptian wisdom, were solving the same puzzle centuries apart, using mud, papyrus, and simplicity. You might wonder, did they yawn over these calculations? Probably not, but imagine them leaning back, rubbing tired eyes, thinking, we've got close enough. We carry their legacy tonight. Enough for bedtime reflection. Before we move on, consider this. Humans didn't stumble onto pi overnight. It took thousands of years and countless quiet nights of fussing over circles and lengths. Imagine those lamplit workshops and temple alcoves filled with low conversations, talk of gods, geometry, and the eternal elbow room between perfection and approximation. So tonight, let these ancient scribes guide your mind into calm wonder, the simple origins of a number that's infinite, elusive, and yet softly human. Now, shift your thoughts to the year 250 BC on the warm, starlit island of Syracuse in what is now Sicily. In a stone courtyard under a sky of drifting clouds, there sits a man who may have been the most brilliant mind the ancient world ever knew, Archimedes. Draped in a loose robe, hair wild like his thinking, he's crouched over a sand table. His fingers trace circles, triangles, and more circles, whispering to himself as though he's trying to eavesdrop on the language of the gods. Archimedes wasn't just a thinker, he was a doer, a builder, and a mathematical poet. And his obsession, the circle. How do you measure it perfectly? He didn't have calculators, no decimals, no symbol for pi, just chalk, shadows, geometry, and patience. But here's what made Archimedes legendary. He decided to trap the circle. He took a simple idea, polygons. First, he inscribed a hexagon inside a circle, then a 12-sided shape, then 24 sides, then 48, then 96. Imagine it like folding a paper shape again and again, closer and closer, until it hugs the circle so tightly that the difference between its perimeter and the circles becomes almost undetectable. He compared the perimeter of the inscribed shape inside the circle and the circumscribed shape outside the circle and squeezed pi between the two. The result? He found that pi was between 3 and 1/7, 3.1428, and 3 and 10/71, 3.1408. Pretty close, right? Even today, Archimedes' method is admired as one of the earliest and most elegant approximations of pi. But picture the man, kneeling in sand, scratching out shapes by torchlight, maybe muttering, This is getting closer. No textbooks, no buttons, just pure thought and trial. We romanticize it now, but Archimedes likely dealt with frustration, chalk dust in his eyes, and maybe the occasional amphora of watered wine to ease the headache. He would go on to invent levers, catapults, and war machines that terrified invading Romans. But even when surrounded by war, he preferred circles to swords. In fact, when a soldier finally cornered him during the siege of Syracuse, legend says Archimedes shouted, "Do not disturb my circles," just before the soldier, misunderstanding or not caring, cut him down. His final thought? Probably about the math, not the man. There's something poetic in that, isn't there? The most famous mind of his time, snatched away in a moment while chasing a number that would never end. Tonight, as you drift off, let your thoughts follow Archimedes' spiral of polygons, smaller, tighter, quieter, like breaths before sleep, approaching perfection, but never quite reaching it, just like pi. The strange thing about numbers is that they often existed long before they had names. Pi had been studied, debated, scribbled on clay, sand, parchment, and blackboards for thousands of years. Yet for most of that time, it had no symbol, just words, descriptions, fractions, no clean shorthand. Imagine trying to talk about infinity without the word infinity. So for centuries, mathematicians wrote things like, the ratio of the circumference of a circle to its diameter, every time, over and over again. That's not exactly sleepy math, that's exhaustion math. And then, in 1706, something elegant happened. A Welsh mathematician named William Jones decided enough was enough. In a little book with a long title, A New Introduction to the Mathematics, he wrote 3 little strokes that would change history. Pi equals 3.14159. Why pi? Because it's the first letter of the Greek word perimetros, meaning perimeter, fitting, since we're talking about the measure around a circle. He wasn't the first to use it in private notes, but he was the first to put it in print. Still, Jones was a relatively unknown figure. He was friends with Newton, yes, but his symbol didn't catch on immediately. Then came the heavy hitter, Leonhard Euler. If you're not familiar, Euler was a Swiss mathematician who, in the 18th century, basically left his initials on every major branch of math. Algebra, geometry, calculus, graph theory, number theory, you name it. If math were a city, Euler would have highways named after him in every district. Euler adopted pi in his works around 1736, and when Euler uses something, it sticks. Soon the symbol pi spread like wildfire, across Europe, across textbooks, across time. It was short, simple, and carried the weight of millennia. And here's the funny part. William Jones is often forgotten, and Euler gets most of the credit. There's something poetic about that too. Pi itself is a number that never ends, never repeats, never settles, and the story of its name is just as wandering. But once it had a symbol, pi became something more than a number. It became a character in the great play of mathematics, a recurring figure, a kind of quiet celebrity, mysterious, infinite, clean, yet unknowable. Imagine writing it for the first time, a single swoop of the pen, a gentle curl, P. It's beautiful in its simplicity, so compact, yet carrying the endless, just like a circle, just like the night. Tonight, as you lie in bed, you are surrounded by invisible piss, every curve, every clock, every planet turning in its orbit. The world is full of quiet circles, and in every one of them, there it is again. 3.14. It took humanity thousands of years to name what we already felt was there. Something constant, something just out of reach, something quietly perfect. And we gave it the softest of names. Pi is not a normal number. You might say that no number is normal, but pi takes it personally. It doesn't end, it doesn't repeat, it doesn't fall into patterns, it doesn't give you anything back for your effort. Write it out as far as you like, 100 digits, 1,000, 1 billion, and it just keeps going. An endless parade of digits marching forward without ever circling back, which is ironic for the number that describes circles. Most of us know it as 3.14159. Some of us can go further, 26535 maybe. But no matter how far you go, there's always more. Mathematicians call it an irrational number, which means it can't be expressed as a fraction of whole numbers. No matter what neat little ratio you try, pi always slips between your fingers. But that wasn't enough. In the late 1800s, a German mathematician named Ferdinand von Lindemann took it further. He proved that pi isn't just irrational, it's transcendental. That means it isn't the solution to any algebraic equation involving whole numbers. Not only can you not measure it exactly, you can't even calculate it exactly using the tools of traditional math. In simple terms, pi lives in its own world, unreachable, a ghost in the machine of numbers. And yet, we keep trying. Humans have spent centuries chasing pi's digits. You'd think after a few hundred decimal places we'd give up, but we don't. In ancient China, Zhu Chongji, in the 5th century, calculated pi to 7 decimal places, 3.1415927, which was remarkably accurate for someone working without trigonometry, logarithms or calculators. 1,000 years later, Madhava of Sangamagrama, an Indian mathematician, devised infinite series to calculate pi more accurately, laying the groundwork for calculus centuries before Newton. In the modern era, things went from slow to obsessive. The invention of computers supercharged the hunt. In 1949, the ENIAC computer calculated pi to over 2,000 decimal places. By the 1980s, we had millions. In 2019, a Google employee named Emma Haruka Iwao used cloud computing to calculate pi to 31 trillion digits, and as of 2022, it's over 100 trillion. Why? What's the point? Well, some people run marathons, others knit giant sweaters, mathematicians chase pi. There's no practical reason to know pi beyond maybe 40 decimal places for any engineering purpose. NASA could get a spacecraft to Pluto and back using just 15. But there's something comforting about chasing an infinite thing. Pi becomes a meditation, a way to measure our patience, our curiosity, our technology. In 2015, a man named Rajveer Meena recited 70,000 digits of pi from memory. It took him over 10 hours. He wore a blindfold the entire time, sitting in a room with nothing but numbers in his head. Think about that. While most of us can't even remember where we put our keys, this man carried a stream of digits longer than most novels, entirely in his mind. Maybe that's what pi is, not just a number, but a mirror. You stare into it, and it shows you how far you're willing to go. It shows you the beauty of never being finished. So as you lie back now, breathing gently, imagine a line of digits trailing into the dark, past your thoughts, past your dreams, curling gently like the spiral of a snail shell, like galaxies turning in silence. The number never ends. But you don't have to follow it. You just have to let it carry you, one number at a time, forever. We often think of pi as something abstract, a number written in textbooks, scribbled on whiteboards, passed around in dusty math classrooms. But pi isn't just a number we invented. It's a pattern we discovered. A fingerprint left by nature, repeated in places we never expected. You'll find it in the petals of flowers, in the spirals of seashells, in the gentle ripple of water. Wherever there's a curve, pi quietly appears, not shouting, not demanding attention, just whispering, "I'm still here." Consider the way light travels in waves, the formula that describes the shape of that wave. It uses pi. Or think about sound, music, speech, the rustle of wind, the wavelengths, the oscillations, the rhythm of it all. They live in sine waves, and sine waves live in pi. In fact, every time you hear a note or feel the vibration of a string, pi is helping shape that sound. It's the ghost in the equation, the silent partner in every hum and echo. Even DNA, the tiny blueprint of life, carries curves and coils shaped by pi. The double helix twists in precise, repeating geometry. We don't always see it, but pi is buried in the blueprint of being alive. It's in the orbits of planets, the ripples of space-time, the architecture of atoms. Everywhere something turns. There it is again. Pi. It's in the way rivers bend. Yes, even the meandering of rivers tends to a ratio involving pi. A surprising 1996 study found that the average ratio of a river's actual length to the direct distance between its source and mouth is close to pi. Even in chaos, pi finds a foothold, and it doesn't stop with nature. Let's talk about people. In 1988, a physicist named Larry Shaw worked at the Exploratorium in San Francisco. He was the kind of guy who loved science and a good pun, and he noticed that March 14th, 314, looked an awful lot like 3.14. So he brought in pies, literal pies, blueberry, apple, pecan, and he said, "Let's make this a celebration." He walked in circles. He played pie-themed songs. He called it Pi Day. A few years later, schools and scientists joined in. Eventually, in 2009, the US House of Representatives passed a resolution officially recognizing March 14th as National Pi Day. Now, every year on that day, people bake pies, memorize digits, write poetry, even get married. Some high schoolers eat exactly 3.14 slices of pizza. Others recite digits until their throats are dry. It's strange how a number that never ends has become something to celebrate, something people gather around, something human. And speaking of stories, there's a novel, you may know it, Life of Pi, a boy stranded at sea, a tiger named Richard Parker, a story within a story and a question at its heart. What kind of story do we prefer? The dry, factual one, or the magical one? And the answer is simple, the one with meaning, the one that brings comfort, the one that helps us sleep. Tonight, Pi is that story, a circle drawn not to trap us, but to hold us. It's the quiet rhythm behind music, the curve of the moon outside your window, the shape of the world, and the shape of the thoughts that drift in your head before sleep. Endless, yes, but familiar, and always returning. just like a lullaby. It might seem strange to talk about emotion and pi in the same breath. After all, pi is a number, cold, rational, abstract. But ask the people who've spent their lives with it, the ones who write its digits by hand, chase it through code, or whisper it into microphones for hours, and they'll tell you something different. They'll tell you that pi is not cold, it's warm, endlessly warm, because it's endlessly familiar. In a world that often feels fragmented and chaotic, there's something comforting about a number that never changes. 3.14159. The beginning is always the same. The digits never shift, never betray you. No matter where you are in the world, a chalkboard in Tokyo, a textbook in Paris, or a whispered memory in your bed, it's still pi. It connects you to something vast. You don't need to be a mathematician to feel it. You only need to be a human being who has ever looked up at the moon and wondered how far it is, how it moves, and why it feels so round. Artists are drawn to pi. Poets too. There's a form of poetry called poems, where the number of letters in each word matches the digits of pi. Here's a simple one. Now, I, even I, would celebrate in rhymes unapt the great immortal number. 314159926. It's silly and beautiful and real. Some people create pi music, assigning notes to digits and letting the number compose melodies, soft lullabies made by math itself. Others make pi quilts where each square is a digit and the blanket spirals into infinity. It has become an identity, a comfort object, a quiet obsession. And isn't that a little like love? Something that doesn't always make sense, but draws you in deeper and deeper the more time you spend with it. There are people who describe pi as a kind of mathematical religion, not in a spiritual sense, but as a ritual. Something that gives their day structure, something to return to. When they feel anxious, they recite pi. When they feel lost, they draw circles. When the world feels messy, they think, at least this is still true. And maybe that's why we love it, because pi reminds us that in an unpredictable world, there are still constants, still things that hold, still patterns that exist beneath the noise. It reminds us that not everything has to end, that there's beauty in the infinite, that the universe still sings in secret harmonies. So tonight, as your breathing slows and your mind begins to float, let the digits drift with you, not because you need to memorize them or solve them or even understand them, but because you too are part of a pattern, a soft curve, a gentle shape, and somewhere inside you is pi. Not every story about pi takes place in the stars or in the minds of ancient mathematicians. Some stories happen in courtrooms. Yes. In the year 1897, in the state of Indiana, pi was nearly made illegal. Or, to be more precise, it was almost redefined by law. This is the story of the Indiana Pi Bill, and it's as bizarre as it sounds. It begins with a man named Edward J. Goodwin, a physician and amateur mathematician. He believed he had discovered something incredible, a method to square the circle, an ancient geometric problem that had stumped minds for centuries. To square the circle means to construct a square with the exact same area as a given circle using only a compass and straightedge. A fun puzzle, and one that mathematically had been proven impossible just 15 years earlier, in 1882, when Lindemann proved that pi is transcendental, but Goodwin disagreed, passionately.
He came up with a series of mathematical assertions and decided to publish them in the hope that the state of Indiana would recognize his method and make it official. And so, in 1897, Indiana House Bill 246 was introduced. Now, the bill never explicitly said we are changing the value of pi, but it made such wild mathematical claims, implying that pi was equal to 3.2, or even 4 in some interpretations, that the implications were clear. It passed the Indiana House of Representatives unanimously. Why? Because very few lawmakers understood the math, and Goodwin's confidence was persuasive. He even offered the state royalty-free use of his discovery. It sounded generous. It sounded smart. But here's where the story gets funny, and maybe a little comforting. As the bill moved to the Indiana Senate, it came across the desk of a visiting mathematician named Clarence Abiathar Waldo. He was a professor at Purdue University in town lobbying for university funding. When he read the bill, he nearly dropped it. He realized immediately that the math was nonsense. So he spoke to the senators, calmly, gently. He explained that Goodwin's method wasn't just flawed, it contradicted centuries of proven geometry, and within minutes, the entire Senate reconsidered. The bill died. Pi was safe. But imagine it. If Waldo hadn't been there, just visiting on that particular day, Indiana might have passed a law declaring that pi equals 3.2, not because they were malicious or foolish, but because math, when misunderstood, can sound like magic. And that's part of the charm of this number. Even something as eternal as pi can get tangled in human politics. It reminds us that even truth needs advocates, that even constants need defending, that sometimes the most powerful argument is a quiet one, made in a hallway by a tired professor with a pencil in his pocket. Tonight, pi still lives on, not as 3.2, but as something infinite, something beautiful, and thankfully, not legislative, because you can't write a law that contains the infinite. You can only listen to it. Close your eyes now and drift upward, past the rooftops, past the clouds, past the stratosphere. Let's take a quiet trip to space, because even out here, in the vacuum between stars, pi is everywhere. Let's begin with orbits. When a planet like Earth dances around the sun, it doesn't move in a perfect circle. It's more of an ellipse, an oval. But the math of those ellipses, still filled with Johannes Kepler, the man who defined the laws of planetary motion in the 1600s, used pi constantly. He showed that the area of an ellipse, just like a circle, could be measured with pi. Without pi, we couldn't calculate the time it takes for planets to complete an orbit. We couldn't land rovers on Mars. We couldn't even point a telescope at a distant star and trust the trajectory. In 1977, NASA launched the Voyager 1 spacecraft, a machine designed to explore the outer solar system and keep going. It's still traveling today, carrying with it a golden record, a message to any intelligent life that might find it. On that record are greetings in 55 languages, music from Earth, and diagrams. One of those diagrams shows the hydrogen atom, another shows the position of Earth, and yet another, a simple circle. Why? Because no matter where in the universe you go, the ratio of a circle's circumference to its diameter, pi, stays the same. Pi is a universal constant, not just to us, but to any creature anywhere with an understanding of geometry. You could meet an alien species with purple skin, 6 elbows and a language of blinking lights, and they'd still know pi. That's beautiful, isn't it? A number that transcends not only cultures and centuries, but worlds. In the International Space Station, astronauts use pi to calculate everything from fuel use to docking angles. Every movement they make is planned using circular motion, arcs, orbits, rotation. When NASA plotted the path of the Perseverance rover to land in a Martian crater just a few meters wide, that was pi, in the math, in the code. And maybe the most poetic example, the cosmic microwave background, the faint whisper of radiation left over from the Big Bang, forms patterns in the sky, and when scientists measure those patterns, pi is there too. It's in the very shape of the universe. Some even speculate, and this is purely speculative, that if we could measure the curvature of all space and time, pi might shift, ever so slightly from what we expect. A cosmic hint that we're living in a curved universe. But for now, as far as we can tell, the universe is round, and pi is still pi. So tonight, as you lie beneath your blanket, imagine you're beneath another one, a sky filled with stars, galaxies, spirals and rings, a universe shaped by pi, quiet, eternal, and spinning slowly, like a lullaby written in number. Of all the curious things humans do, memorizing pi might be the most delightfully useless, and that's what makes it so charming. You don't need to know 1,000 digits of pi to bake a pie, land a plane, or even launch a rocket. In fact, for any practical purpose, 3.4359 is more than enough. But still, people do it. Thousands of digits, tens of thousands, even more. Why? Let's go back to Rajvirmena, the man from India who recited 70,000 digits of pi in He sat blindfolded in a room at VIT University, whispering one digit after another for nearly 10 hours straight, no breaks, no errors. He didn't do it for fame. He didn't do it for fortune. He did it because, in his words, pi is peaceful. Think about that. Peaceful. A number so often seen as endless, irrational, even maddening, and yet, when recited slowly and rhythmically, it becomes something else. A meditation, a mantra, a mind palace, built entirely out of numbers. Many pi memorizers use a technique called the method of Loshi, or the memory palace method. They associate each digit with a location in an imagined space, a hallway, a street, a childhood home. One digit goes in the kitchen, another in the hallway, another behind the couch, and so the number becomes a journey. They walk through the rooms of their imagination, picking up the digits one by one like little trinkets left behind, and in doing so, they calm their minds. They organize the infinite. It's not about math anymore. It's about control, about peace. In Japan, school children celebrate Pi Day with contests. In Germany, memory athletes compete. In the US, students proudly write poems with word lengths that mirror the digits of pi. There's even a subculture of people who try to feel pi, not just remember it, but turn it into art. They make songs where each digit becomes a note. They paint canvases where each color is a number. They choreograph dances to the beat of pi. The goal isn't perfection, it's immersion. To step inside the number, to be surrounded by it, to let it rock you, gently, like waves in a sea of decimals. Maybe that's why pi is so popular in sleep stories, because when you listen to the digits, when you fall into their rhythm, something interesting happens. Your brain stops grasping. It starts drifting. Pi becomes a soft rain of numbers, not meant to be counted, just felt. So tonight, whether you know one digit or 10,000, let pi do what it does best. Let it keep going. Let it never end. Let it lull you into that peaceful, beautiful space between thoughts, where numbers die and sleep begins. Throughout history, mathematicians and mystics have often shared one quiet, curious belief that numbers are sacred. Long before modern calculators and chalkboard equations, ancient cultures saw math not only as a tool, but as a mirror of the cosmos. Take the Pythagoreans, for example. These were followers of Pythagoras. Yes, the triangle guy. But they weren't just interested in right angles. They believed that the entire universe was built from numbers, that harmony in music, proportion in art, and the turning of the stars were all mathematical truth. And among their sacred symbols, the circle, no beginning, no end, a loop without flaw, a symbol of unity, of balance, of eternity, and at the center of that shape was pi. To the Pythagoreans, pi wasn't just a measurement, it was divine proportion, a glimpse into the hidden architecture of everything. Fast forward to the Renaissance. Artists like Leonardo da Vinci and architects like Filippo Brunelleschi used circles to shape cathedrals, domes, and sacred art. Their proportions were driven by geometry, and at the heart of their designs, you guessed it, pi. Even the Great Pyramid of Giza has sparked theories about pi. Some believe its dimensions encode the ratio, suggesting an ancient awareness of this constant, whether intentional or coincidence. The harmony of the structure has captivated minds for millennia. Then there's the mandala, found in Hinduism, Buddhism, and other traditions. Intricate circular designs meant for meditation and spiritual focus. Each curve, each loop, each repeating petal, a journey inward, a return to center, and just beneath the surface, the silent geometry of pi. Modern mystics, too, see meaning in this number. Some say it reflects the infinite nature of the soul. Others view it as proof of divine design, a pattern that appears too often and in too many places to be random. Even the word pi itself, simple, compact, mysterious, has a strangely spiritual rhythm, one syllable, and it goes on forever. Of course, science sees it differently. To the rational mind, pi is a consequence of geometry, a truth of shapes, a necessity. But to the dreaming mind, it's something more. It's a spiral, a halo, a soft glow of logic wrapped in mystery. So whether you see it as math or magic, fact or feeling, pi holds space for you. Tonight, as your thoughts slow down and your breath deepens, picture a mandala spinning slowly, not to dizzy you, but to soothe you. Let its lines guide your eyes inward. Let the loops soften the edges of your thoughts. And let pi, gentle, eternal pi, remind you that there's peace in the pattern. And maybe, just maybe, a little wonder too. You might not expect to find pi in your favourite movie, or your favourite cartoon, or the lyrics of a song you hummed without thinking. But like a good story, pi always shows up in the background. It's the quiet cameo star of pop culture, blinking at you from chalkboards, sneaking into jokes, or hiding in the plot of a sci-fi film. A kind of private wink between the writers and the nerds in the room. Let's start with the obvious. The 1998 psychological thriller, Pi, directed by Darren Aronofsky, a black and white fever dream about a brilliant haunted mathematician who becomes obsessed with finding patterns in nature and believes pi is the key. As the story unravels, so does wall scribblings, nosebleeds, conspiracies. It's not exactly a lullaby, but it is a reflection of the strange hold this number has had on human imagination. More light-hearted is The Simpsons. In one episode, Lisa, the ever-curious intellectual, casually drops the value of pi to 40 digits. It's a blink-and-you-miss-it moment, but one that delighted math Later in another episode, Homer writes a chalkboard formula so close to solving Fermat's last theorem that it sparked debates online, briefly. Pi appears in Futurama, Doctor Who, and even Star Trek. In Voyager, a sentient alien intelligence tries to communicate with humans by transmitting the first 20 digits of pi, because what better universal language than a number shared by all geometry? Even video games haven't resisted its charm. In Portal, the rogue AI GLaDOS recites the digits of pi during a moment of corrupted calculation, a subtle reminder that even machines dream in circles. And then there's music. Yes, some artists have turned pi into melodies. Kate Bush released a track titled Pi, where she gently sings the digits, not all of them correct, which became part of the charm. Others, like Michael Blake, composed entire classical pieces where notes correspond to digits in the number. It's strangely soothing, and a little hypnotic. Books? Of course. In Contact, Carl Sagan imagines a message from aliens hidden deep in the digits of pi, suggesting that the universe itself might be a construct coded with intention. You'll also find pi as a quiet detail in Marvel films, sci-fi novels, and even quirky comedies like The Big Bang Theory, where it's both punchline and sacred symbol. Why does pi keep showing up? Because it's recognizable, but also mysterious. It's math, but it's poetic. It says, hey, I see you, you're one of us. And for those who notice it, it's a little gift, a secret handshake, a hidden code, a thread that connects all the curious minds in the room. So tonight, if you ever find yourself rewatching a cartoon, or hearing a line of dialogue that includes 3-4, and somewhere, someone else is smiling too, wrapped in their blanket, letting numbers rock them to sleep, counting circles instead of sheep. Let's talk about something a little wild, but softly, gently, like a bedtime secret. Pi doesn't end. Not even after a trillion. It keeps going. You could spend the rest of your life writing digits of pi and never ever reach the end. And even stranger, there's no pattern, no repeating loop, no rhythm to its madness. It's what mathematicians call an irrational number, a number that cannot be expressed as a simple fraction. No matter how hard you try, pi will never equal AB, where A and B are integers. And it's not just irrational, It's transcendental, which means it's not the root of any non-zero polynomial equation with rational coefficients. In simpler words, you can't pin it down with normal math. It floats beyond fractions, beyond equations. It is by definition free. Imagine a number line stretching out into the darkness, and somewhere along that line is pi, glowing faintly, spinning, endless. The first few digits, 3.1459, are just a hello. After that, a jungle of randomness. No digit ever takes over, no sequence repeats. There are 6s and 7s and 2s, but never in predictable ways. If you dig deep enough, you'll find your birthday in pi, or the number of your childhood home, or mathematically speaking anything. Some even wonder, is pi a container of the universe? Does it hold the works of Shakespeare encoded in digits? Your name, your dreams, your memories, all hiding somewhere in the cascade of numbers? We don't know, and we probably never will, because we can't reach the bottom. As of today, pi has been computed to over 100 trillion digits by supercomputers. Not because we need that many digits for science, we don't, but because we can. Because chasing infinity is what humans do. We explore, we dig, we count, not to conquer, but to understand. And pi, quietly, rewards us with more digits, more mystery, more mathematical wonder. Tonight, let your mind imagine a spiral staircase made of numbers. Each step is another digit of pi. You can walk it forever and never reach the top or the bottom. You're simply inside it, floating gently, breathing softly, resting in the idea that some things, like dreams and sleep and the number pi, never really end. Let's leave the chalkboards and textbooks behind and wander into something lighter, something a little sweet, because every March 14th, that's 314 on the calendar, something quietly magical happens. The world celebrates Pi Day. Yes, an entire holiday for a number. And while it's not quite as loud as New Year's or as flashy as Halloween, Pi Day has its own charming rhythm, full of inside jokes, curious minds, and a little whipped cream on top. It started in 1988, when a physicist named Larry Shaw and his co-workers at the Exploratorium Science Museum in San Francisco decided to honor pi with a circular celebration. They ate fruit pies, they marched in circles, they laughed. A small idea shared by a few. But math has a funny way of multiplying. By the 2000s, Pi Day was being recognized around the globe. Schools began holding competitions to see who could recite the most digits. Libraries stacked circular treats by the door. Professors gave quirky lectures, starting precisely at as in 3:14:59. Some people wear shirts, others bake, some just quietly tip their head to the infinite. At MIT, Pi Day is more than fun. It's tradition. The university often releases its admissions decisions on March 14th, which for many students turns pi into a number they'll never forget. In Japan, Pi Day has become a gentle celebration of math itself, of curiosity, patience and pattern. In Germany, it's celebrated with pun-laden poems with a syllable count matching the digits of pi. And then there are the obsessives, the ones who write pi songs, who memorize digits by the thousands, who host piathlons, running 3-4 miles while balancing math trivia. And of course, there's pie, sweet cherry, tart lemon, classic apple, a nod to the circle, to comfort, to joy wrapped in pastry. And isn't that perfect? That we celebrate one of the most infinite abstract concepts in mathematics, with something warm, soft and edible. Pi, the never-ending number, honored with something that has a crust, a middle and an end. Maybe that's the balance, maybe that's the beauty, that in between the calculations and the digits, we find time to laugh, to bake, to share. Pi Day reminds us that math isn't cold, it's human. A number that unites mathematicians, students, bakers and dreamers, all tracing circles around a sunlit table. So tonight, as you lie in your bed, let your thoughts spiral once more, gently, like whipped cream on pie. There's no rush to solve anything, only time to wonder. And maybe tomorrow, when March 14th rolls around again, you'll smile and think of pi, and maybe reach for something sweet. Let's step outside now, not far, just into a quiet meadow, or maybe a silent forest path, dappled with starlight. And let's notice something together. Circles are everywhere. Look at a raindrop, a ripple on a pond, the shape of the moon, the rings inside a tree stump, counting seasons in silent loops, from the smallest patterns to the grandest celestial forms. Nature seems to whisper one thing over and over again: round, round, and behind every circle, pi, a quiet signature from the universe, a mathematical fingerprint on everything curved. Let's begin small. The cells in your body, many are circular, not because it's stylish, but because it's efficient. Circles enclose the most area with the least perimeter, so they're stable, compact, and elegant. Same with bubbles. Why are soap bubbles spherical? Because surface tension pulls equally in all directions, and pi governs the math behind their curves. Even the dew forming on leaves at dawn follows this rule. Tiny domes shaped by tension and geometry. Zoom out a little. Think of spider webs. Those symmetrical marvels spin out from a center point, each thread forming a radial line built around a hidden circle. And yes, pi is there too. In plants, spirals often grow in patterns related to the Fibonacci sequence, a cousin of pi in the family of mathematical beauty. The head of a sunflower, the curl of a fern, the shell of a snail, each curve, each sweep, measured in part by pi. Now look to the sky. The moon rises, round and glowing, a soft circle etched onto the night. Planets are round, not by chance, but by the forces of gravity pulling equally in all directions. This spherical shape, a three-dimensional cousin of the circle, is a physical echo of pi's presence in the laws of the universe. Tides, they follow the curves of Earth's rotation and the moon's orbit. Once again, even storms like hurricanes form into spirals, coiled circles of motion with a quiet center. Isn't it strange? A number, born from simple geometry, the ratio of a circle's circumference to its diameter, turns out to be everywhere, not just in equations, but in petals and puddles and galaxies. You don't need to see pi written down to feel its presence. You can sense it in the way things curve, a whisper of structure, a reminder that math isn't invented, it's discovered. It was always there, so tonight, let your breath take on the rhythm of a circle. Inhale, round the corner, exhale, complete the loop, pi beneath the surface, always turning, always guiding the shape of things. After all this talk of loops, spirals, and endless digits, it makes sense that we end where we began, with pi, a number you've known since grade school, a number you've probably doodled into notebooks, or memorized to a few decimal places. But now, maybe it feels a little different, not just as a tool for geometry, but as a character in the story of the universe, a soft, steady constant in a world that rarely stays still. There's something comforting about that, in a reality full of surprises, where traffic jams appear without warning, and toast always seems to land butter side down. Pi never changes, no matter how chaotic the day has been. No matter how strange or shifting life may feel. 3. It's the same on paper, on Mars, on a far-off planet light years away. It's the same today as it was when Archimedes first scratched circles into the sand with a stick. It'll be the same tomorrow and long after we're gone. That's rare, that's grounding. Some people find comfort in rituals, some in prayer, some in the hum of a refrigerator, or the ticking of a clock. But for others, quiet thinkers, gentle night owls, dreamers with tired eyes, there's comfort in knowing that some numbers never break, they just continue. And maybe that's why we've spent the past 2 hours together, not solving problems, not proving theorems, but simply being with pi, letting it drift through history, through architecture, through art, through space, through circles drawn in the margins of ancient books, through pies and pyramids, sonnets and star charts, and now finally through sleep. And voices soften. and the endless rhythm of pi continues in the background, like a lullaby written by the universe. So close your eyes and rest in the comfort of the constant, not because you understand every decimal, but because you don't have to. You're part of the story now, and it never ends. Thank you for joining me on this quiet journey through the winding world of pi, a number that never ends, and a story that always continues. From the minds of ancient thinkers to the patterns in petals and stars, we've seen how something so small, just 3.14, can hold the weight of wonder, memory, curiosity, and calm. If this helped you drift off or simply brought a moment of stillness to your day, there are many more journeys waiting for you here. This channel is dedicated to slowing things down, to exploring the world through the lens of numbers, patterns, and quiet fascination. So if you'd like to fall asleep to more soft-spoken mathematics, subscribe for new videos every week. From fractions to Fibonacci, from 0 to infinity, there's always another story to tell, another number to follow, another evening to spend together. Until then, rest well, stay curious, and may your dreams be endless, just like